Hello everyone, it's Benny, and welcome back to building a better redstone computer. Last time, we built this awesome cache, and it's great, but throughout our build there's just a few, how can you say, small, very subtle things that have happened, and just a few tiny ways we can make it better. So, before I move on to the major topic of this video, I just want to take a moment and implement those few minor tweaks we can do to just make this whole system just that much better. So, let's go ahead and let's get started. Our first tweak comes from this, the input to our cache from RAM. So the RAM data in signal strength form will come in to the bottom one, go through here, and it will always be decoded to 15. That's not what we want. It's just a small bug, not because of anything wrong with our system, really, just I missed a few things when I was stacking this with World Edit. So I'm going to go ahead and correct that right now. This should be decoding to 10, and there's two reasons it's not. One, down here, there's supposed to be comparators here and here in our conditional subtractor. See, they're there for everything else. But for whatever reason, they were not in my World Edit selection when I copied, so yeah. Small error, very easy to fix. Just don't forget to do this, or, well, your system won't work. But you come over here, you notice this still isn't decoding correctly. This is not 10, this is still 15. And the reason becomes obvious if you fly, well, maybe not right there, but maybe right here. See, this is supposed to be just a block with that over it all the way through, and this is supposed to have a torch similarly. And yeah, again, just another relatively minor issue that, for whatever reason, just wasn't in my World Edit selection. And this particular one, I really have no idea why that wasn't in World Edit, but hey, it's how things were. So, I'm just gonna deal with it. And there. Now, I don't think there's anything I need to do over there, so this should now be decoding correctly. Which, of course, it is not. So let's just reset it because it is still not working correctly. Okay. This is weird. One moment. And the reason I'm having a problem is for some reason this furnace also didn't get stacked all the way down. I'm really a little bit baffled here, don't know how that happened, but yeah, put a furnace with power 8 there. Over here, you will need a furnace of power 4. So I don't change anything there, just put the furnace down. And finally, I should need a furnace of power 2. And now, there we go. Now this is correctly decoding this as 10. And if I back off just a little bit more, that's 9, 8, 7. Sure, 7. Let's do 6. That'd be interesting. So decode 6. Voila, there's 6. So very cool. This should all be working now without any real problem. Okay, so our next small little tweak and improvement happens to also be in the cache write system. Though don't worry, not all of them are right here. Someone pointed out in the comments last time, hey Benny, why are you using 2 comparators here? You know, you really only need 1. And you just have to set it up a little bit differently. So what you have to do is put it in subtract mode, have slabs, that tower's going to be a little different, but that's okay, and then output right there. So the slab tower would be, just if I break this for a moment, here, and this, well, would be in subtract mode. When this turns off, things will go through, not quite far enough, so I'll need to replace this signal strength 2 furnace with a signal strength 3 furnace for this to work. And other than that, really that's just about all there is to it. This turns on. There you go, nothing. This turns off. Hey, and if this has power, then it subtracts enough power that it doesn't reach anymore. So yeah, sort of like an AND gate. It only turns off if both of these are off, so I guess more like a NAND gate, but you know, you get the idea. So yeah, now I'm just going to do a little bit of stacking and place this everywhere. So this will mess up our write system, but we'll fix that in a moment. So this is position 1, and this should be position 2, and I think that's right. Should be able to expand one down, stack. Well, let me break this first. Alright, I'm back. Sorry about that. But yeah, I selected my positions. Now I should just be able to stack 7 down, and what do you know? All appears to be well. I mean, aside from the fact that, you know, doesn't quite work with our read system, but that's okay. So I've just expanded 14 down, and now I should be able... Actually... that's why the furnaces got messed up. Okay, so here's what I'm going to do. I'm going to expand 1 and contract 1. And I think this should just about capture everything. So now, if I stack 2, yeah, that stacks and does not destroy all the furnaces. Now, I do still need to fix this one, but that's okay. I'll do that in just a moment. Right now, I just want to make sure I didn't break anything again. So yeah, I will have to change this manually. That's okay. I'll actually go ahead and do that off-screen, since it should be easy enough at this point. Okay. I went ahead and built the slab tower, and basically set this up like everything else we just did. So, our next problem is this right line. It no longer works with our different oriented slab tower. So I'm just going to do something pretty simple. I'm going to put a torch here, and a block with redstone on top. And that should power the entire slab tower with more than enough to spare to not really make any impact at all on the actual write bus. So, cool. This does mean we're going to need to move our line itself a little bit, but that shouldn't really be an issue. Not really. So I'm going to just go ahead, do this, and go down. And yeah, this is how we're going to do it. So I'm going to go over 2, and here. That should be good. So now if I just set... yeah, this is position 1. And... okay, this is going to be tricky. This, as position 2, I need to expand 1 down, and I need to expand... see, I can't expand more up at all, actually, or else I'm going to run into the same problem I had before with the missing stuffs. So I'm just going to go ahead and stack... I'm targeting to stack 3 times without interfering with anything, so... actually, let me do it one more time, just to see. Okay, does not interfere with anything, we're good. So I can now break all of these lines. And good. Now we do need to do a few things manually, but that shouldn't be a big deal. You just need to do this a couple of times. Well, specifically 3, but, you know. And we're good to go. Oh, I guess I do need to still relabel the line, but, you know, not a big deal. Not that hard. And read decoded RAM to cache registers. Perfect. Now our new line is working. I can decode some stuff just for the sake of decoding stuff. Nothing happens. If I read, hey, we have it not quite working. That's a not good, as they say. Okay, I discovered the problem, and I decided to go ahead and fix it off screen because I think it's not that hard to do. And I'm feeling like this is already taking too much video time on these supposedly small tweaks. But yeah, this row of furnaces, or column of furnaces I should say, are all 8. For some reason, all of those rows of furnaces had been set to 8, probably due to some inexpert world editing I did at some point. So just this column should all be 4, and this column should all be 2. If you correct those, everything works as intended. And now that this has caused far more trouble than I intended, and probably more trouble than it was worth, I think we're finally done messing around with our cache write system. And we should, keyword should, be able to go ahead and play around with our next tweak. So, in the carry logic of our ALU, we have a generate signal giving full signal power to the input of this comparator, and a cancel signal giving full power to the side of this comparator. That, for the most part, is what we want. This works just fine. The trick is our vectorize function. If this is on, then this gives full power to right here, which means this cancels, which means the cancel signal above has 1 less signal strength than the generate itself. Basically, the signal strength is slightly off, and we need to adjust our generate signal to fix it. So I'm going to put power here instead, and this will work just fine. It won't be an issue that the cancel signal is stronger than the generate, but if generate's stronger than the cancel, we get a false carry. So, yeah, I'm not even going to use world edit for this. Very simple tweak. Just go all the way down, replacing the torches like this. Almost. Right here, we do still want to use this. And that's just so that the signal strength will reach all the way to the top. But, yeah. So there we go. Now, our vectorization function should work just fine, and we won't have any kind of signal strength issues coming in and interfering. So, now that all the minor tweaks are out of the way, the big thing I wanted to cover in this video is flags. And you might be wondering, hey Benny, what are flags? Well, if you've been paying close attention so far, you might have noticed there's a few pieces of information that our ALU computes, but we aren't actually doing anything with. Like, for example, the carryout. What do we do if there's a carryout? Right now, we just ignore it. Same thing if we shift a number left, what do we do with the uppermost bit that's shifted out? It could be 1 or 0. Do we do anything with that? And same dilemma for the right shift, way down here. And these sort of one-off pieces of data that it's hard to say what you do with them in general, but in a few specific cases they might be very useful. Those are ideal candidates for flags. And the idea is pretty simple. Every time we compute something with an ALU, we will save all these flags, and we'll make them accessible to the programmer, so the programmer can check the flags and react to them however he might want to react to them. So it can be very useful. And we're going to go ahead and get started with that. Firstly, by introducing a new flag, the 0 flag. What this flag will do is it will be on if and only if the result of the ALU is 0. So, yeah. And to do this, we need just a tiny bit of extra space. So I'm going to take our accumulator right here, and it's position 1 and position 2. And I'm just going to move it over 1. And I'm going to put a few blocks here so that it's still powering all the repeaters. But yeah, the big reason is this just gives us a tiny bit of extra space over here to implement the 0 flag. And we'll need it. And same thing over here with our vectorization. I'm going to go ahead and break that. I'm actually going to change it up. I'm going to have a second repeater here, have a block. I'm going to make our vectorization go around in sort of this crazy diagonal, not quite diagonal, I don't even know what you'd call this shape, but this crazy pattern with lots of repeaters. And it's okay that it has this delay because our vectorization, not time critical. It doesn't really matter too much how fast it is to enable or disable vectorization, so not worried about it. But yeah. So, what I'm going to do is I'm going to have a repeater here. This is coming from the 8th bit. I have a repeater here. And you notice power is coming from the 7th bit into the block out of the repeater. And I can just sort of follow this sort of staggered pattern all the way down. And you might be reasonably asking why I need to do it like this. You'll see in just a moment. But yeah, I want to have this nice staggered pattern to slowly repeat every single one of our bits outwards. So that, well, we can do the flags. And I'm going to do that, and lastly, bit number 1, the lowest bit. So just need to go over here, and there. So the reason I did everything, well, like I just did, is mainly because it lets us create a tower. That is, the spiral tower thing. I don't know what you call it. The spiral climbing tower of Redstone. You know what I mean. I'm sorry, I'm back. But yeah, the spiral tower, the spiral staircase, that's the name of it. I'm sorry. But, whoops. No. So yeah, we're just going to build a spiral staircase all the way up. And that's how we're going to connect all these wires. So, basically, all these repeaters are going to power this same wire going up in a spiral staircase. The idea is, if any of them are on, then this entire spiral staircase will be powered. Because if I power this, look at this, power reaches all the way to the bottom. Powered at the bottom, power reaches all the way to the top. So, this is good. This is just a nice way of making sure we reach everything. In fact, let's see just how far this does go down. Not that I really need it that much, but it's good, just curiosity point. Alright, so that's as far as it goes down. Good to know. And, technically speaking, you don't need all these repeaters here. You could just, do, like, redstone dust, kind of like this. And that'll save you, well, actually, you can't get rid of that. You will need, well, I guess you could do something like this and go up one. There, and this will allow you to do it in 2 ticks, but, again, I'm not too fussed about performance of this, so I'm just going to break some random wiring and set it up. So cool. Just like that, our 0 flag is good and raring to go. Okay, so I went ahead and changed our vectorization command back to the no repeater version because, it's faster and I don't really have a good argument against it, so why not? Doesn't hurt anything. But yeah, our next flag is the carry flag. So for our carry out here, I'm going to send it through a repeater and right here. Now you notice this is right next to our shift left output flag. And I'm going to say this is also a carry out flag. And really this is just a simplifying assumption. These are both operations that will ultimately set a hypothetical 9th bit, so really for the most part you can treat them the same and it's not really of much consequence. Also, it makes rotation instructions kind of easier, as you'll see, well, whenever we get there. But yeah. So what I'm going to do here is I'm going to go down a bit, and I'm essentially just going to make a second spiral staircase heading down. And that's pretty much my game plan here. So, yeah. And the one thing you're going to have to be careful of is because we're starting from farther up, there won't be as much room to go down with this particular, well, in this particular spiral staircase, as opposed to the 0 spiral staircase. In fact, if I power it, I should be running out of power pretty soon, actually. Probably even like in the next block or 2. I think that's probably it, actually. Yep, that's it. So, at this point, what I would do is I'd invert it to go down a little bit farther. And this... Oops, let me just go ahead and break my temporary torch up here. And this is where we're going to handle the rest of the carry flag. It's going to go... Well, I mean, there's two ways you could do this. You could do it kind of like I'm doing, with a torch like this. Or you could get creative and find a way to squeeze a repeater in somewhere, like, say... Well, you couldn't squeeze it in there, because that would, you know... And you also couldn't squeeze it in here, because that would power that. So, I don't know where exactly you'd fit in this repeater. I guess maybe going this way somewhere, but... You know, that's another option. But I'm just going to do it with a torch. And I'm going to go down here, because that's about as far down as I really need to go for now. I don't really need to go any deeper. Because I'm still not really doing anything with these flags yet. I'm still just sort of having them there, hanging around. So you might be wondering, hey Benny, what do you do with all these flags? Find out next time. Hope you enjoyed, hope you learned, and I'll see you next time.